Hi guys, this is Samiksha and I'll be talking about security and protection features in Linux. This is the session outline. After a brief introduction, we'll see the definition of protection and security and the key differences between the two. Then we'll move further to see protection features in Linux and security features in Linux. Now, Linux is a multi-user operating system, so we want to ensure that each object is accessed correctly and only by those processes that are allowed to do so. We also want to protect the system against unauthorized access and malicious threats. What is protection? Protection refers to the mechanism which controls the access of programs, processes, or users to the resources defined by a computer system. We need protection to prevent the access of unauthorized users and to ensure the active programs or processes in the system use resources only as the stated policy. What is security? Security refers to the specified steps or measures used to protect the operating system from threats, viruses, bombs, malware, or remote hacker intrusions. Security can be violated by any of the breaches mentioned: a breach of confidentiality, that is, unauthorized reading of data; breach of integrity, unauthorized modification of data; breach of availability, that is, unauthorized destruction of data; theft of service, that is, unauthorized use of resources; and denial of service, which is preventing legitimate use of the system. Now, although protection and security sound very similar things, but there are certain key differences between the two. Protection deals with access to system resources, whereas security grants the system access to appropriate users only. In case of protection, internal threats are involved, whereas in case of security, external threats are involved. Protection determines what resources can be accessed by a user, whereas security decides which person is granted access for using the system. In case of protection, authorization mechanism is implemented, whereas in case of security, encryption and authentication mechanisms are used. Now we'll move on to see some protection features in Linux. We'll first have a look at permissions. There are three types of permissions in Linux: read, write, and execute. Read helps us to read the file's contents or list the directory's contents in the case of a directory. Write helps us to modify the file's contents or remove or rename files in the directory. Execute helps us to execute or run the file or make the directory as a current working directory. Permissions are represented as a string of 10 characters, wherein the first character can be either be a dash or D. A dash indicates regular file, whereas D indicates directory. Then it is followed by three triplets of RWX each, wherein the first one indicates the permissions for the file owner, the second triplet indicates the permissions for the groups, and the third triplet indicates permissions for all other users. Now read, write, and execute, they have been assigned numerical values 4, 2, and 1 respectively. Now we can look at this example, how symbolic modes can be changed into numeric mode and why it is beneficial. For example, we have this string written here. When we convert it into binary, R will be given a 1, W will be given a 1, and a dash means that the permission is denied, so we denote it as a 0. We write the whole string in the binary, and then when we convert it into octal, we get 644. And here you can see this R dash dash, it got converted into 4. And this is exactly the way it got assigned numerical value 4. And similarly with write and execute. Now we'll come and see ownerships. There are three types of ownerships in Linux: user groups and others. A user is the owner of the file, and by default the person who created the file becomes its owner. Groups: a user group can contain multiple users. All users belonging to a group will have the same access permissions to the file. Others: any other user who has access to a file. This person has neither created the file nor he belongs to a user group who could own the file. So practically, it means everybody else. Now here are some useful commands that we can use to manage user groups. Add user can be used to add a user to the system. User del to delete a user account and related files. Add group to add a group to the system. Del group to remove a group from the system. User mod to modify a user account. Change mode to change access file permissions and directories. Now we'll have a look at SA Linux. SA Linux is nothing but Security Enhanced Linux. It is a Linux kernel security module that provides a mechanism for supporting access control security policies, including mandatory access controls. Now we'll have a look at security features in Linux. We start with user authentication. Now when a computer user wants to log in into a computer system, then the installed OS on that computer system generally wants to determine and check who the user is, and this process is known as user authentication. Linux primarily uses a one-way encryption algorithm called DES, Data Encryption Standard, to encrypt passwords. The encrypted password is then stored in etc password or etc shadow. Now, when you are attempting to log in, the password you type is encrypted again, and then it is compared with the entry in the file that stores your passwords. Now, if the two match, you are allowed to access. Now, Linux pluggable authentication module SPAM provide dynamic authentication support for the applications and services in a Linux system. Linux SPAM separates the task of authentication into four independent management groups: account modules, authentication modules, password modules, and session modules. Now we will have a look at Linux hardening. Linux hardening is nothing but the act of enhancing the security of the system by introducing proactive measures. We are just trying to reduce the surface of vulnerability. Now there are various ways of hardening the Linux system. These are only a few of them. Physical system security, that is, configure the BIOS to disable booting from CD or DVD, external devices, floppy drive, and BIOS. Next, we enable BIOS password and also protect grub with password to restrict physical access of your system. SSH, Telnet, and RLogin protocols uses plain text, not encrypted format, which is why there is a security breach. SSH is a secure protocol that uses encryption technology and during communication with the server. Keep your system always updated. Always keep your system updated with latest releases of patches, security fixes, and kernel when it's available. Then there are some more ways. Enable SE Linux. Security Enhanced Linux or SE Linux is a compulsory access control security mechanism provided in the kernel. So disabling SE Linux definitely means removing security mechanism from the system. It's in its name itself. If it is security enhanced Linux and you are disabling the thing, you are definitely going to get into trouble. Then we have enforcing stronger passwords. A number of users use soft or weak passwords, and their password might be hacked with a dictionary based or even brute force attacks. The PAM cracklib module is available in PAM, that is pluggable authentication modules we already learned, which will force the user to set strong passwords. Enable IP tables, firewall. It is highly recommended to enable firewall to secure unauthorized access of your servers. Apply rules in IP tables to filter incoming, outgoing, and forwarding packets. Now with this, we come to the end of the video. Thank you so much for being patient listeners, and good luck.